So the reason why this is going to be easy is because you've already learned this. Now, everybody had a different situation last year with a different teacher, so maybe you didn't remember learning this, which is fine, but we're going to learn it right now, okay? Does yours say 1, 2, 3, or does it say 4, 5, 6?
1, 2, 3. 1, 2, 3.
Okay, half of you probably say 1, 2, 3, half probably say 4, 5, 6. So if yours says 4, 5, 6, just change it to 1, 2, 3. I don't want you looking back and thinking you missed a page because it starts with step 4. Okay, so step 1, 2, 3. Right? All right. So this unit is going to be solving equations. I cannot stress enough how important this unit is going to be in all of your future math classes. There will be some things that we learn in here that don't really come back up, or they may come back once and then go away. But this unit, the stuff that we're going to learn, the processes and the steps and everything, will be in every math class you take for the rest of your life, okay? Even in college, if you go to college, okay? So I cannot stress how important it is. If there is ever a time to get your you-know-what together and lock in, right now, this unit is that time, okay? We're going to start with some real easy stuff before break, just because it's kind of review. Once we come back from break, we're going to continue on, introduce some new stuff, kick it up a notch a little bit, and get a little bit more difficult. But overall, if you're engaging with this and working through it how we're supposed to, it shouldn't be too bad. This should be really straightforward, okay? One-step equations. Here's how we're going to solve. A lot of teachers taught you this last year. The first thing you're going to do is split your equation into two sides by putting a line through the what? Equal sign. Okay, imagine playing volleyball without a net. It's kind of hard to tell which side is which, whose team is whose, right? So we're going to make a line through our equal sign that kind of serves as our net in a way, just to separate the left side from the right side. Today it won't be that important, but it's something that we're going to start doing today and continue doing this entire unit so that it sticks in your brain. Once you have that split up, a lot of times students look at an equation and go, I don't really know what to do. All you have to do is ask yourself a very, very simple question. That question is, what is happening to x in this equation? Right? If I look down at this first problem, x plus 4 equals 10, I'm going to split my equal sign just like that. Some teachers call it a fence, right? In the same way with the net, you know whose house is whose by where the fence line is. And then I look here, x plus 4. If I asked you what is happening to x, what would your answer to that question be? We're adding 4. Pretty straightforward, right? Give me a thumbs up if you see that. I'm adding 4 to x. Good. Some of us, this may be an over-explanation. I promise it's worth it. Whatever the answer is to that question, as Z just helped us out with, the answer was I'm adding 4. I'm going to do the inverse, write this in red, inverse operation on both sides. What's another word for inverse? I'm thinking of a word that starts, yeah, Vanessa? Opposite. We're going to do the opposite. So Z, what did you say is happening to x in this very first equation? We're adding 4. What would the inverse of addition be, you guys? Subtraction. Right? So if I see, hey, I'm adding 4. Yes, sir. Scribble on a blank page for a little bit. Just get it started up. Some of them are new. If you see that dark ink in the pen, it's definitely not empty. You just got to get it going. There we go. I told you, you just got to get it going. That's it. Okay? So, again, what is happening to x? I'm adding 4. I'm going to do the inverse of addition, which is subtraction, and I'm going to do it on both sides. So with our red pen, everyone hold up your red pen if you got it. Yes? Okay? If you have your own red pen, that's fine too, whatever you want. I'm going to write underneath plus 4, I'm going to write minus 4. And where else am I going to write minus 4? Under the 10. Thank you, Xavier. Under the 10. This line that we're drawing, we can think of like a mirror. We talked about reflections already. Whatever I see on one side of the mirror, I'm going to see on the other side. So if negative 4 is on the left, I got to have a negative 4 on the right. Does that sound good so far? Okay. What's that? Perfect. That's good. What we're going to do now without the red pen, with your pencil or your regular pen, whatever color, underneath this, we're going to write a big line. Kind of like those old school like addition problems that maybe you learned in elementary school where it's something like, 12 plus 7, and then you draw that line underneath. What that line tells me is that underneath this is my result or answer. Exactly. So if I'm subtracting 4 on both sides, I'm going to get a result. Let's see what that result is. What is 4 minus 4? 0. Do I need to write plus 0 in my equation though? No. All I'm going to do is cross those two guys out. Right? Yes, sir. I would like you to do it like this for now. If down the line in this unit you find a way that works better for you, then that's great. I see what you did, and that's good that we're connecting that. Once we get into like more difficult equations, we're going to need to know these steps. So for now, let's do it with these steps, okay? But that's great. What is 10 minus 4?
6.
6.
Sorry.
No, I appreciate it. What happens with my x? Did I do anything to x?
No.
No, I just bring it down. And there's my answer. How many steps was that?
3.
Okay, it was 3 with the line and the... But all we did was subtract 4. That's why it's called a one-step equation. Okay? Now, like Josh pointed out up here, he was like, well, I know that 6 plus 4 equals 10. I can just say x equals 6. You're absolutely right. With one-step equations, that will work just fine. But if we don't get comfortable with... Is this the right notebook? If we don't get comfortable with these steps right now, once we get to something that looks like... What is it? Okay? Once this is a little bit more than one step right here. Okay? I can't look at 2/3 x plus 2 equals 8 over 9 and in my head kind of fill in the blank with what x is, right? So trust the process. I've done this a couple times. This is the best way to do it, just like this, okay? But if you're seeing connections, that's awesome. Really good job. Let's move on to the next one. What's the very first thing I want to do here?
Add a line.
Add a line. I'm going to split my equal sign. I'm going to ask that every time. That's always going to be the answer. Now I'm going to ask myself, what is currently happening to x here? We're subtracting. We got a minus. I'm subtracting 3. Well, what's the opposite of subtracting 3? Adding 3. In the same way that the opposite of addition is subtraction, the opposite of subtraction is addition. That's why we got this little double-sided arrow here. It switches both ways. Am I just going to add 3 to the left side?
No, put it on the other side.
That's right. I'm going to put it on the other side as well. What am I going to draw underneath this? A horizontal line to show me now I've got a resulting equation. What happens with my x? Nothing.
Bring it down.
I just bring it down. What is negative 3 plus 3? 0. Johnny. We talked about that before. Negative 3 plus 3 is 0. I'm just going to cross those out. Now what is negative 5 plus 3?
2.
Negative 2. Negative 2. All right? So this little part here, this negative 5 plus 3, if you forgot how to do it, I've got a great spot for you to look. The very, very, very first thing that we've ever done in our notebooks on August 20th was exactly this process. Doing the 2, you guys remember this with the 2 minuses, the plus and the minus? Okay. Don't worry, you weren't here. Yeah, you came a little late. A couple of us came a little late, that's fine. It's just some addition stuff. There's my answer. X equals -2. Let's go to this next one. What's the first thing I want to do here?
Draw the line.
Draw the line. Now, my 6 and my x, I don't see a plus in between them. I don't see a minus in between them. Vanessa, what am I doing to x here?
Divide.
Divide?
Or multiply.
We're multiplying. This is 6 times x. You guys see that?
Yeah.
So what's the opposite of multiplication?
Dividing.
Dividing. So on the left side, we're going to divide by 6. And on the right side, we're going to divide by 6. Okay? Because if I'm multiplying, multiplication, the inverse operation there is, of course, going to be division. Everybody cool with that so far? Okay, I'm going to do a big line underneath to show that I've got a new equation. What happens with my 6 over 6? Nothing. We cross them off. What is 6 over 6? 1. So here, -3 plus 3 gave us 0. We crossed them off. Here, 6 over 6 gives me 1, but I'm still going to cross them off. Why? Why can I cross them off? Why don't I need to put the 1 there?
Because the x is 1.
The x is 1. It's my invisible 1. Great job. So the 6's go away, leaving me with x. And what is 24 divided by 6? How many times is 6 going to 24?
4.
4 times. There's my answer. Now again, you may look at this equation and go, oh, 6 times what equals 24? Obviously my answer is 4. And that's a great way for us to easily check our work by using that little, recognition. But we still got to do these steps because we're going to build and build and build on these steps. We're starting with 1 step. We're eventually going to get to like 6 or 7 steps, okay? So we got to make sure we're building up nice. If we don't get a foundation right now, our whole house is going to fall down once we get to the more difficult stuff, okay? Do you guys know it's the 67th day of school today?
Yeah, actually.
Yeah, that's why teachers are wearing like 6, 7 necklaces and stuff.
Really?
Yeah, you'll
Do
see.
you not see like the posters because they have them?
Didn't feel like it. My fake purple jeans. I could have. I think I gave Johnny my purple jeans tag, so
Yeah.
that's fine.
Johnny always looks.
Okay. Yeah, I remember you came up. I called you twin because we kind of look alike. You know what I mean?
just kind of look alike.
All right. Let's move on. Second row. Second row. Look at this guy. We're gonna split the equal sign. X over 4. I don't see an addition. I don't see a subtraction. What am I doing to x here?
Multiply.
We're dividing it by 4. So the opposite of dividing it by 4 is multiplying. Now, this one's going to be a little bit different. Okay, hold on. We're not going to write it underneath. We're going to write it off to the side. Times 4 times 4. That little dot, of course, meaning multiplication. Yes. Are you talking about like this one down here? Here? Oh, we'll get there. Don't worry. Let's go one by one. But yes, we'll do something with the negative for sure. I'm glad you pointed that out. So here, 4x over 4. What happens once again to my 4 over 4? It's just 1, so I can cross them out. I'm going to do my line underneath. What's the only thing left on the left-hand side? Left-hand side? X equals, and what's 2 times 4? Boom. It's not too bad, right? So that's my first 4. We saw what it looks like to subtract on both sides, add on both sides, divide on both sides, and multiply on both sides. Those are my 4 operations. Okay, any questions on those basics? Quick show of thumbs. How are we feeling about it? Thumbs up. I remember this. Seems easy enough. I think I can do that. Thumbs sideways, a little bit iffy. Okay, good. Yeah, up. Good. Joseph, yep. Great. Now let's get into a couple interesting looking things. Here I'm going to split my equal sign right down the middle. And I see I have x minus negative 2. We got to clean that up a little bit. It's a loud no. Does anyone remember what happens when I have two minus signs right next to each other like that?
It becomes addition.
Good morning. Sure. Thank you. Two minus signs right next to each other, you guys remember?
Becomes addition.
A positive, that's right. The way that we talked about this the very first week of school, if I got these two minus signs right here, right? No number in between, they're like magnets. They attract, boom, that's right, and they swing together and make that plus. So I want to turn these two minus signs into one big plus sign. Right? Now I see that I'm doing what to x here with x plus 2? I'm adding. So what's the opposite of adding 2? Subtracting 2. My 2's go away, leaving me with x equals, what's 7 minus 2? 5. Right? The reason why this is important is because you'll look at this and go, oh, I see a minus there. I must be adding 2 to both sides. But that's not what we're doing. We got to combine those signs first so that we know what to do on both sides. Is that one okay? Okay. Now this next one. This one is also tricky. You see that minus sign and your brain goes, oh, I'm going to add 10 to both sides. Why would we not be adding 10 to both sides? It's a negative number that we're doing what with the x? Multiplying. That's right. So when my number is kissing that letter, when they're bumped up next to each other with no sign, it's always multiplication. I can multiply by a negative number. That just means I'm also going to be dividing by that negative number. And you will end up with a negative. That's right. What happens to my negative 10s on the left? Cross them out. Thank you. Leaving me with x. Now, how many times does 10 go into 90? 9 times. And what's a positive over a negative? Negative. Great job. Does that clear that up, Avery? Was that your question? Yeah, if there's a negative number in front, we're just dividing by the negative. Yes. Because if we just divide by 10, now it's negative x equals 9. I have another step, which we're not even going to worry about. So just cancel everything out in 1, divide by negative 10. All right? Now this one, I've got negative x over 2. Okay, what am I doing to x here? If I have it in a fraction, I'm dividing. And I'm dividing it by negative 2. Even though the negative's not, right next to the 2, it's still part of it. So if I'm dividing by 2, what's the opposite of dividing by 2? Multiplying. But in this case, I'm going to multiply by negative 2. I don't know where this line went. Are you guys missing that line too?
No.
Some of you are, some of you aren't? That's weird. That's okay. So negative 2 over negative 2, we're going to be able to cancel those out nicely, leaving us with x equals, now what's a negative times a negative, you guys? A positive. And what's 5 times 2? 10. So not only can we divide both sides by a negative, we can multiply both sides by a negative 2. Yes, sir? Sure. Yeah, go ahead. Now this one, my order is a little bit different. I got 5 plus x equals negative 2. What am I doing to x here? Yeah, Ukamba?
Minus it by 5.
So that's what we're going to do. What are we doing to x right now? Look, do you see this right here? What do you see? You're adding. So the opposite would be, like you said?
Minus it.
Minus it. Exactly. What happens to my 5 minus 5? Cross them out, goes away, leaving me with x equals, now this is tricky, Some of us are gonna mess this up. What is negative 2 minus 5?
3.
3. That's what I was hoping I wouldn't hear. Negative 7. Okay. As I've said, maybe like 30,000 times, if I spend $2, right, and then spend $5 more, how much did I spend in total? 7. Okay. That's how we got to think about this. Negative 2 and negative 5 make negative 7. Okay? And finally, we got this one, 2x equals 1. What am I doing to x right here with that 2 kissed up against it? So you're one step ahead of me. We're multiplying it by 2. What's the inverse of multiplying by 2? Dividing by 2. Okay, what happens to my 2 over 2 here on the left? Cross it out, it equals 1. And what is 1 over 2? 0.5. I'd like you to keep it as a fraction. We'll just call it 1 over 2. So we can have a fraction as our answer. It's not very common, but it might happen. You guys feeling good with this?
Yes.
Yeah, pretty easy, right? So you guys won't be mad if there's like 30 questions on the homework,
I would be mad.
since it's so easy.
I will.